Hello, everybody, and welcome to the free code camp Blockchain and Solidity Beginner to Expert Full Course Python Edition. We're going to go through everything you need to know for developing on a blockchain using Solidity and engaging in the future of finance. We're going to cover topics that will teach you all the skills you need to become a smart contract expert that you can take with you no matter which blockchain you're developing on. Blockchain engineers are in extreme demand, and they're building billion-dollar applications almost every day at this point. At the time of filming, protocols like Aave, Yearn.finance, and Synthetics have billions of dollars of locked value in them, allowing people to engage in decentralized finance, or DeFi. This allows people to make censorship-resistant moves and so much more. Some of these protocols with billions of dollars are even less than a year old. So whether or not you're brand new to this space or you've been in here a while, hi, my name is Patrick Collins and I live in the smart contract world. I'll be taking you through your journey to becoming a blockchain and smart contract expert. A little bit of background on myself. I'm an engineer and developer advocate on the Chainlink protocol. And I also have my own blockchain infrastructure company called Alpha Chain, where I run different nodes and different infrastructure for blockchains, including one of the main technologies we're going to be talking about today, which is Ethereum. I love being a pioneer in the smart contract ecosystem, and I love taking new users like yourself along to the journey with us. And we are going to teach you to become a smart contract expert. Building blockchain and Solidity applications is building a world of more trust and accountability. It means building a financially free future, and we get to be the ones that will go down in the history books as the pioneers of this space. Additionally, blockchain and smart contract engineering skills are some of the most sought after in the world, with an average salary of a Solidity developer being between $150,000 and $175,000. In this video, we're going to teach you how to become one of these developers and go out into the world and participate in the world of smart contracts and the world of blockchain. This course is ideally for engineers who know a little bit of Python programming, and you can have any level of smart contract engineering. Whether you're a complete beginner to blockchains and you don't even know what one is, or you're an advanced Solidity engineer and you're looking to learn more, this is the perfect place for you. Having a little bit of experience in other object-oriented programming language like JavaScript as well will be helpful here too. And if you're brand new to coding in general, that's all right, because we're going to take you step by step through everything. If you do want a little bit more in-depth Python coding video, there is a fantastic free code camp video in the description. If you do prefer JavaScript, we will also be releasing a JavaScript edition of this video as well. But everything that you learn here will be applicable there, and if you watch both, you'll learn even more.
You can find the entire itinerary for this entire course along with all of the code associated with everything that we do, and additionally discussions and support and everything else in this Smart Contract Kit / full blockchain Solidity course, Pi GitHub repository. It has a table of contents and then the entire itinerary of everything that we're going to go over in this course. And like I said, with helpful tips, resources for getting support, and resources for getting help.
Now, for your convenience, every single piece of code that we're going to go over in this video has a GitHub repository associated with it. So be sure to grab the link in the description, grab that GitHub repository, and look through all the different repos that we're going to give you. If you ever get lost or need to refer to some code or want to copy paste some code, all of it will be there for you. It'll also be a great place to reference in the future when you're working on some project and you want to remember how to do something. So be sure to start and refer back to it as you watch this video. So let's talk a little bit about some best practices for watching this video. This space moves really quickly. So if we show you some documentation, it might be a good idea for you to open that documentation up as well, read through it as we do, so you can stay up to speed. Now, we've packed a ton of information in this video, and studies have shown if you try to digest a massive amount of information in a short period of time, your retention isn't as good. So it's highly recommended that every 25 minutes to half an hour, you take a 5-minute break, and then every 2 hours, maybe you take an additional 30-minute or an hour-long break. You can pause, bookmark areas, and come back later and learn at your own speed. There are timestamps in the description that will help you come back to where you left off. And you don't even have to go in order. If you want to bounce around from topic to topic, you're absolutely free to do so. We're also going to get really technical with the fundamentals of blockchain, and if you want to just jump right into Solidity, you can jump down the timestamps below and get right into it. And if you're watching this on YouTube, you can adjust the speed that I talk and that I give this presentation. So if I'm talking way too quickly for you, you can slow it down. Or if I'm talking too slowly for you, you can have me speed up. So be sure to set me at the pace that you like best. You are highly encouraged to pause, come back, and ask questions. The blockchain and smart contract world is a very collaborative community. So if you have questions, some of the best places that you can go, going to Stack Overflow and tagging your question with the specific technologies that you're working on, make an issue on the GitHub repo that we're working with, go to Stack Exchange ETH and make a question there as well, jump into the Discord of the technology that you're working with, or even on GitHub discussions if those are there. Learning to become a blockchain and Solidity engineer is actually a lot more than just learning Solidity. Becoming comfortable with all the tools in the space is going to be just as essential as becoming familiar with Solidity itself. And continuing the conversation on maybe Twitter or Reddit or any of these other channels, and maybe even showing your stuff in the next Ethereum or Chainlink hackathon are going to be majorly beneficial to increasing your skill as an engineer. Now, before we get actually coding, a lot of people want to understand what is actually happening with all this blockchain stuff. What is blockchain? What is a smart contract? How did this all get started? And understanding these core fundamentals will actually shape the way you code and architect your smart contract applications. So learning these is really, really critical. However, if you're already familiar with blockchain and you just want to jump into the Solidity, feel free to grab a timestamp from the description and jump to that section. Now, since you're here though, you've probably heard of Bitcoin before. Bitcoin was one of the first protocols to use this revolutionary technology called blockchain. The Bitcoin white paper was released by the pseudo-anonymous Satoshi Nakamoto, and it outlined how Bitcoin could be used to make peer-to-peer transactions in a decentralized network. This network is powered by cryptography and allows people to engage in censorship-resistant finance in a decentralized manner. Due to some of the features of Bitcoin, a lot of people took it to be as a superior store of value over another asset like, let's say, gold. And that's why it's commonly referred to as digital gold. Similar to gold, there is a scarce and set amount of it on the planet, and people use it to buy and sell, similar to other assets. You can read more about the original vision in the white paper, and there's a link to it in the description. Now, this was a fantastic breakthrough, and in a little bit, we're actually going to look through how blockchains can actually work and how all of this is possible. But some people took this and saw this technology and thought that they could do even more. A few years later, a man named Vitalik Buterin released a white paper describing a new protocol called Ethereum, which used this same blockchain infrastructure, but with an additional feature. And in 2015, they released this project called Ethereum. Him and a number of other co-founders took this blockchain technology and applied it in ways that people can make entire decentralized applications, decentralized organizations, and build smart contracts and engage in agreements without a third-party intermediary or centralized governing force. Their idea was to take the same pieces that made Bitcoin great and add smart contracts to it. And in fact, this technically wasn't even a new idea. Back in 1994, a man named Nick Szabo proposed a technology called smart contracts. A smart contract is a self-executing set of instructions that is executed without a third-party intermediary. They come to life on a blockchain. And these smart contracts are really going to be the core thing that we're going to be working with and we're going to be developing. Smart contracts are similar to regular traditional contracts that people make between each other. But instead of writing these contracts down on pen and paper or typing them on the computer, it's entirely written in code. The terms of the agreement are written in code and automatically executed by the decentralized blockchain network instead of being written in pen and paper and executed by the 2 parties or 3 parties or however many parties involved. This was one of the main differentiators between the Ethereum protocol and the Bitcoin protocol. Now, technically, Bitcoin does also have smart contracts. However, they're not Turing complete, meaning that they don't have the full range of capabilities as a Turing complete application like Ethereum. This was actually an intentional move by the Bitcoin developers. They view the Bitcoin network as an asset, whereas Ethereum and the Ethereum developers viewed that asset as an asset and also a utility for people to build these smart contracts. Now, these smart contracts are revolutionary technologies, and we're going to talk a little bit more about what their advantage is in a little bit. But they actually come with a fatal flaw with what's known as the oracle problem. These blockchains are deterministic systems, and we'll learn why they're deterministic very soon. And this determinism means that they're a walled garden, meaning that everything that happens in these smart contracts and on this blockchain happens in this little box. Now, of course, if we want these smart contracts to actually be these digital superior agreements, then they need some way to interact with the real world and get real data and external outside the blockchain computation. This is where oracles come into play. Oracles are devices that bring data into a blockchain or execute some type of external computation. So great, so oracles are the solution. Now blockchains can talk to the real world, right? Well, not quite. Our blockchains and smart contracts are these decentralized applications. And in order for them to stay decentralized, that means they would also need to get their data and external computation from a decentralized manner as well. Your on-chain logic will be decentralized on the blockchain, but you'll also need your off-chain data and external computation decentralized as well. Combining these on-chain logic settlement layers and these off-chain data and external computation builds what's called hybrid smart contracts. And a large majority of DeFi applications and the largest applications today are these hybrid smart contracts. This is where the protocol Chainlink comes into play. Chainlink is a decentralized modular Oracle network that allows you to bring data into your smart contracts and do external computation. And it's these hybrid smart contracts that can have this on-chain settlement and interact with the real world in some meaningful way. Chainlink is an incredibly powerful Oracle network because it allows us to get data, get randomness, do some type of upkeep, or really customize our smart contracts in any way we want and elevate them to do anything that we want them to do. Now, throughout the course, when we're talking about smart contracts, oftentimes we are also talking about hybrid smart contracts. Smart contracts is used a little bit interchangeably with hybrid smart contracts, but just know that when we say hybrid smart contract, we're talking specifically about smart contracts with an off-chain component. Now, throughout this video, you'll hear people say smart contract, you'll hear people say decentralized protocol, decentralized application, or dApp, and they kind of all are a little bit interchangeable. A decentralized application is usually a combination of several smart contracts, and when we start coding some Solidity, you'll see what a singular smart contract or singular contract looks like. Smart contracts are going to be what we code, write, and deploy for the majority of this video. And learning some of these fundamental concepts will allow us to be better smart contract and better Solidity developers. Now, since its inception, the Ethereum protocol has given rise to many new paradigms and industries, including DeFi, NFTs, DAOs, or decentralized autonomous organizations, layer 2s, and so much more. And a couple of other protocols have taken this Ethereum vision and gone in a different direction with it, like Polygon, Polkadot, or Avalanche. If we learn the core basics of smart contract development on the Ethereum platform, all of these skills translate to these other chains as well. So don't worry about learning a specific tool or chain because most of them work together pretty seamlessly. Now, there are a few exceptions to this rule, and there are some smart contract platforms, aka blockchains, that don't use Solidity. However, learning the fundamental skills here will still translate to every single other blockchain. And Ethereum is by far the most popular and most used smart contract blockchain or smart contract protocol. You'll also hear those words used a little interchangeably as well. Sometimes I'll say blockchain, or sometimes I'll say smart contract platform, smart contract protocol, and the like. Similarly, Chainlink is the most popular and powerful decentralized Oracle network, and is going to be the one that we're going to focus on here. Chainlink is also blockchain and smart contract platform agnostic, meaning it'll work on Ethereum, Avalanche, Polygon, Polkadot, or really any blockchain or smart contract platform out there. Whew. Even in this introduction, we've already learned a lot. So let's do a quick summary of what we've talked about. Bitcoin was the first application to take the blockchain technology into the limelight and into a meaningful way. Bitcoin is a sort of digital gold, able to make transactions between users as almost a sort of currency. Ethereum takes this blockchain technology one step further, but you can also build smart contract or decentralized applications, decentralized autonomous organizations, and more, because you can code with smart contracts. These smart contracts can then access external data and external computation outside the blockchain using what's called oracles. Chainlink is the most powerful decentralized Oracle network and allows us to build these hybrid smart contracts, which is a combination of decentralized on-chain logic settlement layer and any decentralized external off-chain data or computation. Hybrid smart contracts and smart contracts are often used interchangeably. Now, you're probably asking yourself a lot of questions right now, like what makes Bitcoin so interesting? What makes it like a digital gold? And how are these smart contracts going to add any value to the real world? And that's what we're going to go into now. So before